I'm Tim Dudgeon from Informatics Matters. I trust you can all hear me. If not, shout loudly. So I'm going to tell you about the e-infrastructure that has been put together as part of this project. Obviously, being an e-infrastructure project, the e-infrastructure is quite an important part of it. So I shall try to be brief. There is a lot more information behind the scenes and a lot of links shown in these slides. I'm going to quickly run through some slides and then hopefully, assuming we've got some time, do a brief demo and tour of some of these things. So at the heart of what we're creating is what we term a virtual environment, or sometimes we refer to this as a virtual research environment. So in some cases, you'll hear it referred to as a VE, sometimes as a VRE. It's the same thing. And what this is computational infrastructure into which applications can be deployed, and then having been deployed, they can then be used. And that infrastructure, that virtual environment, includes facilities for building and testing applications, as well as just running them. And it includes the necessary compute infrastructure, the security infrastructure, the persistent storage, tools for monitoring and managing the environment, and everything you need in order to have a up and running environment. And one of the key things that makes this probably somewhat different to many other projects is this virtual environment is designed to be deployed to any number of infrastructures. And the expectation is that you as a user might well want to deploy your own virtual environment into your own infrastructure. So here on the right, we've got a sort of graphic that sort of describes what a virtual environment is at a very high level. You've got your tools, or our tools, or maybe even third-party tools that we want to use. Those can be built and deployed within the virtual environment. Alternatively, if you've already got mechanisms for building them, you can stick with those, and you can build your containers and push them into an external registry from where they can be deployed. We're not descriptive on how this is done. The only thing that matters is that you end up with containers that can be deployed. Then the environment contains the computing infrastructure on which these will run. And the net result of this is you have a number of services that you can then access, typically through a web browser or possibly through an API, maybe from other programs. And the key thing that, as I mentioned, makes this different to many projects is that this virtual environment is deployable to your own infrastructure. And by doing so, you would get all of these tools, the apps, the databases made available within your environment, where you can satisfy your own security requirements and your own computing requirements there. And so that it is designed to be deployed either to a single computer, even a laptop. You can deploy this to a laptop. Obviously, the computational power is limited, but you can do it. You can deploy it to your own local data center, your physical servers, or you can deploy it into the cloud infrastructure, whether it be Amazon or Google or Azure or whatever. The aim of the project is to be very agnostic on where and how the virtual environment can be deployed. And so what we provide as part of the project, and we're just over halfway through at the moment, we provide instructions and materials for deploying an OpenRiskNet virtual environment. All of those instructions and the materials you need to do this are contained in our GitHub repository. The link is there. And we aim over time to support a number of cloud providers and a number of different deployment scenarios. So standard availability, high availability, and things like that to meet different needs. In addition, we provide our own virtual environment, which acts as our reference site, which is already up and running. And that's where you can go to test the currently deployed tools. We use that actively for testing. You can get a login to it and start using it to test and evaluate the environment and the current tools that we have deployed. The location is listed here. We'll look at this in more detail in a little while. And just point out that this reference site is intended for evaluation and testing purposes. Don't think of it as a production site that you can use for your own research for high computing tasks or things that will necessarily be stable for over the long period. It's not designed for that. It's designed for testing and evaluation. If you want something for production use, the expectation is you will deploy your own virtual environment either to your own hardware or into the cloud, and you can use that. So what is what forms this virtual environment? It's based around something called the OpenShift Container Platform, which is a product, a project and a product from Red Hat. It's effectively Red Hat's distribution of Kubernetes. Now, if you know what Kubernetes is, then great. If you don't know what Kubernetes is, it probably doesn't matter much. But in essence, it's a distributed operating system for containers. So it allows you to run containerized application across a cluster of computers, and it provides some of the management and capabilities for handling that. It's like a distributed operating system, but designed purely for running containers. It's designed to be run at large scale, but it can also run just on a laptop. One of the key things that OpenShift provides, which, as I said, OpenShift is really just a distribution of Kubernetes with some extra things added on. It's those extra things that are added on that are really important to us and what made us go down this route. And that includes things like continuous integration and continuous deployment capabilities, security features, enhanced monitoring and things like that. A lot of the things that we would otherwise have needed to create ourselves, they just come built into the OpenShift environment, and so we can use them straight away without having to reinvent the wheel there. The project is an open source project, so we can use it for free. Our reference site is built around the open source tools, and I expect most people will similarly want to use the open source tools. But being a Red Hat product, there is the option of getting commercial support. So that would be of interest to many commercial organizations who need something to be a bit more be on a sounder footing. And Red Hat joined the project as a technology partner, so they are actually giving us some assistance and some advice as we go through the project. That interaction with Red Hat is working quite nicely. What does this mean for you if you've got an application that you want to deploy into a virtual environment? Well, if that application is already containerized, it's going to be pretty simple to deploy it to an OpenRiskNet virtual environment. You just need to write some deployment descriptors that describe how it should be deployed. Generally speaking, that's a fairly simple and painless process. If, however, your application is not yet containerized, then it needs to be containerized before it can be deployed. That, in some cases, can be relatively simple. In other cases, it can be more complex. It really depends completely on the nature of your application, its complexity, and what you and how you want to structure it when you deploy it. And you might need to do some refactoring of the application in some cases to allow that. Difficult to comment more generally than that. It's very specific. It's very dependent on your the needs of your individual application. But the bottom line is it's relatively straightforward to get applications into this environment, and in some cases it's very straightforward. The OpenRiskNet reference site that I mentioned earlier, which is where you can go to evaluate and to test things, is running on the Swedish Science Cloud. It runs on top of the OpenStack cloud environment, which is an open source implementation of cloud environments. It's similar in some ways to what you might see on Amazon Web Services or Google Cloud and things like that, but it's an open source public implementation that you can deploy to your own physical hardware. That cloud environment we then use to provision a number of servers on which the OpenRiskNet virtual environment runs. You've got a screenshot here on the right of the OpenStack Console. which is showing the servers that are running. I'm sure you can't see this very well because it's quite small, but basically in there are 15 virtual machines that are running. In total, there's about 100 CPU cores and about 200 gigabytes of RAM powering this environment. So our applications that you're going to see are running across that cluster of computers, and that whole process is managed at the lower level by OpenStack. And at the next level up is handled by the OpenShift product, which is the container orchestration tier that sits on top of the virtualized hardware. And OpenShift is deployed as part of the virtual environment. So when you deploy a virtual environment to your own infrastructure or to the cloud, OpenShift is deployed as part of that procedure. And in doing so, that provides the ability for you to build and deploy your containerized applications and to scale them and to monitor them and to do everything you need to get them into a running system. OpenShift can be accessed through a web console, which is what you're seeing on the right, but there's also a command line application and a REST API that you can use if you need more automation. But the screenshot here on the right nicely shows you one small part of the production site, the reference site, showing the pods. This is where the containers are running, showing how much memory and CPU usage is going on, and it gives you a very nice way of managing this and checking it's all working correctly, and then making adjustments or scaling things up or scaling things down as you need. And basically, the OpenShift console, what you see on the right, or the command line or API equivalents, are what you would use as an application developer or an application deployer. This is what you use to get your applications into a virtual environment so that they can be used by the end users. So examples of how we do this, we've got a number of partner applications that are already deployed. We'll see some of these in a little while. All of these are documented and described in our GitHub repository under this link, where we have deployment templates for all of the applications. If you wanted to deploy your application as an associated partner or as a third party, you would need to create an equivalent of one of these deployments that just describes how that application will be deployed into the environment. Again, we'll see a simple example of this in a sec. A simple example is BridgeDB, which is an application from University of Maastricht, which is one of the partners of the project. This was a relatively simple application to get up and running because it was already containerized. It runs in a single Docker container, and so it's relatively simple to do. So if you want to look at a starting point for how to do this in a simple scenario, BridgeDB is quite a nice one. Just go to this link, and you'll see the instructions and the materials you need to actually do the deployment. And chances are, if you've got a similar scenario of an application running in a single container, you will end up with something that looks pretty similar to that. Obviously, things aren't always simple, and we've got two examples here of things that are quite a bit more complex. One is our Jupyter Hub deployment that gives access to Jupyter notebooks, and the other is the Squonk Computational Notebook deployment, which gives access to the Squonk Computational Notebook. Both of these have multiple components that have to be deployed, and so the deployment is more complex because there are multiple components that have to be linked together, etc., etc. But all the information is there in the GitHub repository, and we're here to help any associated partners in getting through this, getting over the learning curve, and getting up to speed. So that's all about getting services into the virtual environment. And so if we just did that, we'd end up with a lot of services. That would be quite useful. It'd be great to have an environment where you can deploy your services and use them. But that would really only achieve one of our goals. A very important goal for the project is to provide some interoperability between these tools. so that you can use one tool and then another tool. They interoperate nicely. You can pipeline them together, or you can try two tools and compare them and things like that. It's that interoperability and the integration that is one of the key aspects of the project. Again, I don't have time to go into this in any detail, but part is about making that interoperability happen, and we do this by using the OpenShift services. So these are the applications you deploy into the environment that then become accessible as a service, and could be used either by a browser-based application or an API or whatever. And these services are annotated so that they become discoverable. So we'll see an example of how that happens in a sec. But essentially, service sort of sticks up its hand and says, Hey, OpenRiskNet, I've got some services that you might be interested in. Come and find me and discover that service. And what that annotation does is basically it's a callback. It tells you where the REST API of that service is. So just by annotating the OpenShift service with the location of the REST API, the OpenShift environment, or to be more accurate, the OpenShift registry, the OpenRiskNet registry running within the virtual environment, can then inspect that OpenAPI descriptor of the REST API and extract out the information that it needs. And we put into that OpenAPI definition not just the plain OpenAPI aspects, which really defines a fairly sort of low-level description of a REST API, but we semantically annotate it with JSON-LD information that is basically an ontologically driven definition of what that service does. So it describes the inputs, the outputs, the options and things like that. And it lets the registry sort of understand in more detail what the service can do. And the registry is sitting there in the environment, looking for these services as they start up or they shut down, and it's updating its list of services that are available to applications running in the environment. And the registry provides the ability to query for services based on that semantic information that is described through the OpenAPI and JSON-LD descriptors. And to give a couple of very simple examples here, you could query the registry and say, give me all services that you know about that can predict a log P from a smile string. Or another query could be, give me all services that can convert an inchy string into a smile string. And then having run those two queries, you can then join them together. So you could write a process that could generate a log P from an inchy, because we now know how to convert the inchy into a smiles and then run the log P prediction from the smiles. So this semantic information that we enrich the OpenAPI definitions with allows us to start to put together these sort of higher level queries and starts making the tools more interoperable. I don't have time to go into this in much more detail. There is a lot more information available. The registry itself, where you can actually look at which services are running, is there on this link. There's a query tool we've done that lets you run these sorts of execute these sorts of semantic queries against the known services. There's a list of ontological terms that we currently have that we use to annotate these services. That ontology is going to be expanded as the project progresses. And there's a guide to how you go through this process, what you need to do to make your service discoverable. But just to give a very simple example, here is one of our partner applications, the Lazar application. That's basically a toxicity prediction tool using read-across techniques. And the first part was to annotate the OpenShift service to make it discoverable. That was the service putting its hand up and saying, I want to be discovered. And to do that is remarkably simple. You just add an annotation to the service definition with this term, OpenRisk static services, and the value is the location of the service is the location where you need to go to get the OpenAPI definition. So the registry will notice this service as it starts up. It'll spot that it's got this annotation, and it will go to this location, receive the OpenAPI definition along with the JSON LD annotations that describe it. That's the easy bit. A bit more complex is to actually annotate the OpenAPI definition with these JSON LD extensions. And this is a little bit of what this looks like. This definition is actually much bigger than this. This is just a little small snippet of it. But basically, you add to your Swagger OpenAPI definition some of these XORN terms that basically do the annotation of the service. It describes in a semantic way what the inputs are, what the outputs are, what the parameters are, and things like that. And so it then begins to allow us to provide this interoperability. Details of both of these are linked here. That's the template that deploys Lazar and has that single annotation in it. And this is the endpoint. This is what you get if you go to this URL, which gives you a very complex JSON document, of which this is just a small snippet. So that's it for the slides. What I'm going to do now in the remaining maybe 5 minutes is just give you a quick demo of some of these things. There's the OpenStack Console, which you saw on a screenshot, but it was tiny and you wouldn't have seen it. This probably isn't of a great deal of interest to you. It's really more related to the system administrator who is setting up this environment. But on here, we're seeing the instances that we have created. These are on which the OpenRiskNet environment is running. I'm not going to go into that in any more detail. It's probably not a prime interest to people, but obviously it's a very important component of the infrastructure. The next thing I'm going to show is the OpenShift Console. So this does become relevant to application deployers, people who've got an application that they want to deploy into the OpenRiskNet virtual environment. The OpenShift environment is broken up into a number of projects or namespaces that allow you to isolate things and keep different systems separate. In this case, we're looking at the Jackpot project, which is one of our more complex projects. It's one of the applications from the NTUA in Athens. Jackpot is a predictive modeling suite of programs and more than that. So here you'll see quite a large number of deployments. Jackpot is not just one application; it's a number of applications that are being deployed, and the OpenShift console gives you a really nice way to managing this and deploying these things in the first place, and scaling them up, scaling them down, monitoring them, and things like that. If we look at another project, let's go to Jupyter. This is the project where we have deployed Jupyter Hub, which allows you to run Jupyter notebooks. Thomas later on will be showing you a Jupyter notebook, and that is running within this pod here. And you'll see that running later. There's some stuff that is infrastructure. So here's a project that is the what we call the OpenRiskNet infrastructure project, where we have a number of sort of basic things that a number of applications can use. Here's the home, the landing page. This is what runs this website. This is all continuously built and continuously deployed from GitHub. So all we need to do to update this is make a commit into the GitHub repository, and the application is automatically redeployed. We have message queues, we have databases, and we have a single sign-on environment. The single sign-on is very important to us. It allows us to have a single point of access to all of the applications. So if you log in once, you log into all of the applications, assuming you've been granted access to those applications. And it provides a very flexible way of configuring this. So if you're deploying a virtual environment into your own infrastructure, you can hook this single sign-on system into your own security environment. It could be your own Active Directory database, or your LDAP database, or other system support as well. So this is the sort of the adapter from our single sign-on into whatever security mechanism you want to deploy. And then let's look at a couple more quickly. The OpenRiskNet registry. This is the registry application I mentioned earlier, which you can query to find out which applications are running that have been semantically enriched and want to be discoverable. The registry itself is a relatively simple application. It's just a single container, though obviously what's going on in that container is, it is fairly sophisticated. And finally, let's just look at two more things. Squonk, which is the Squonk computational notebook. This is a number of services that we are that are deployed. It's a multi-tier application with a number of different components. Each of these is deployed and made accessible as a service, etc., etc. And finally, we'll look at metrics. But the number of ways we can actually monitor what's going on in the cluster. You'll have noticed a lot of these little sort of graphics going on here, which gives you a continuous way of monitoring how much memory is being used by any application, how much CPU is being used, how much network is being used, and things like that. But there's much more than that. There's tools that let you query and provide dashboards and things like that, and alerting, so you can find out when particular applications are using more CPU than expected and things like that. A good way of managing and monitoring what's going on, which in a distributed system like this is very important. So that's the OpenShift console. As I said, you would use that if you were an application developer, or even more if you're an application deployer. Then those aren't always the same people, but often they are. And finally, we'll look at the landing page. This is the sort of the home page that describes, that lists the services that we currently have available. We're hoping that you, as potential associate partners, will have applications that can be added to this in the future. So this is where you would go to actually start using the infrastructure. There's information here on how to log in. You get a login page like this. And essentially our preferred mechanism of access is through LinkedIn. So basically click on the LinkedIn link there, you would then be taken to LinkedIn. If you're not already logged in there, you'd be asked to log in, and then you would be asked, do you want OpenRiskNet to be given to allow to use that login? We're not accessing any information from LinkedIn. We're just using your LinkedIn login, and it'll tell you we're just using your user ID to identify you, and really not much else. So you would click on LinkedIn. You'd go to the LinkedIn site, or you'd be taken to part of the LinkedIn site to log in, and then when you've logged in, you're then taken back to OpenRiskNet. The same can be done using GitHub. Our preference is to use LinkedIn because that's obviously has much broader adoption. And if neither of those are okay, we can give you dedicated logins, but we prefer not to do that. So that's about logging in. And then if you just want to access an application, you just find the one you want, and it'll take you to the application itself. Let's say we wanted to run a Jupyter notebook. That takes you to there. You say, what type of notebook do you want to run? You say click spawn, and then a minute or so later you'd have a running Jupyter notebook where you could do some work. You'll hear more about this later from Thomas. So I think broadly speaking, that's about all I wanted to go through. There are a number of categories here. End user applications, we'll see both of these later. Graphical applications, so the applications for a particular tool. So very often tools are created with their own user interface. So these are specific user interfaces to those specific applications, whereas these notebook applications are more general workflow tools that can potentially sit on top of a number of applications and let you perform more complex workflows. Some applications that are related more to sort of data sources, some example workflows, some predictive modeling stuff, We've got a number of partners who have some nice predictive modeling tools that are already integrated in, and from those there are a number of models that we've already generated that are accessible, and a number of utilities and helpers and lots of other things. So this landing page is, you know, it's probably the first place to go if you want to look at the OpenRiskNet infrastructure from the point of view of being a user of it. So that is a scientist who's wanting to do something related to chemical safety assessment. So I think that's probably all I wanted to cover at this stage.